All right, next up in section 12.1, we're going to look at question number 3 on the worksheet, which is down below here, and we're asked to find the values of x for which the function is defined. Okay, so before we jump into any of these problems, first just recall what we did in question number 1. Okay, we had the function r of x was 1 divided by x minus 3, and recall when we plugged in x equals 3, right, we ran into a problem. We said, okay, if I have my little table of values here, setting x to 3 led to a division by 0, right? Because I'm doing 1 divided by 3 minus 3, which is 1 over 0, and that's just not defined. Okay, so put another way, right, looking at the original expression here, we are going to be undefined when x minus 3 is equal to 0, right? So if I set x minus 3 equal to 0, okay, this is the same thing as saying that x is equal to 3, right? So I'm saying that the function r of x is undefined when x is 3. So for all other x's, aside from 3, this thing will be nicely defined. Okay, so we're going to do that same kind of thing now for each of these parts. So starting with part A, we have f of x is 4x divided by x plus 7. Okay, so here I'm going to look at the denominator and say, okay, what makes this thing 0, right? A division by 0 is going to be problematic for us, right? So if x plus 7 were 0, so in other words, x were equal to negative 7, right, this function will not be defined. So since the problem is phrased as to find the values of x for which the function is defined, then we can say this, right? We can say f of x is defined for all other x's. So in other words, for x not equal to negative 7, okay? All right, moving on to B. Same kind of idea here. Our denominator is, in this case, x squared, and so we do not want this thing to be 0, right? If it were 0, then the resulting function would just not be defined. So if I set x squared equal to 0 here, well, the only way that this thing is 0 is if x itself is 0. Okay, so that's saying, right, that the function is, so y is defined then for all other x's, right, for x not 0. Okay, cool. So moving on then to C, now our denominator, a little more complicated, is this. Okay, so if that thing were 0, okay, what I'm going to do to solve this is I'm going to do a little factoring like we were reviewing in that section 12.0. Notice there's a common factor of x there, so I'm going to factor that out, and that's going to leave us with 3x minus 2 in parentheses, and that's going to equal 0. And now what I have is something times something else is equal to 0. And so the values of x that will satisfy this equation are going to be such that the first factor would have to be 0. And if that were the case, then x would be 0. Or the second factor here, if this thing were 0, then that whole product would come out to be 0. And that's going to happen when? Well, if I add 2 and divide by 3, that would say that x was 2/3. Okay, so in other words, if I set 0 for x, I'm going to run into a problem because I'll be dividing by 0. And if I set x to be 2/3, right, into this denominator, I'm still going to be dividing by 0. So the big punchline then is that r of x, the function, is going to be defined for all x aside from these two values. So for x not equal to 0 and 2/3. All right, great. And then D, it's the same kind of idea, again, just a little bit more of a complicated denominator here. So if I set this to 0, to figure out the values of x that I'm essentially going to have to stay away from. I'm going to now go ahead and factor the left-hand side, much like I did here. Now this is a trinomial, so I'm going to factor that as a product of binomials. There's no common factor to take out like I saw in part C. So to build the x squared, I'm going to need an x and an x. And then for the 8, I'm going to need two numbers that multiply together that give me 8, and they're going to have to add to -6, right? So something times something else would have to come out to be 8, and then their sum is going to have to come out to be a -6. So if you give that a bit of thought there, -2 and -4 will do the job. Okay, and you can easily check x times x is x squared, -4x minus 2x is -6x, -2 times -4, there's your +8. Okay, cool. So now, again, I have the product of two things, and that's coming out to be 0. So that's going to happen when either the first term here, the first thing in the product is 0, and that would happen when x was 2, or when the second factor here would be 0, and that would happen when x is 4. Okay, so again, to summarize, we would say that our function little r of x is defined when we stay away from these two numbers. So when x is not equal to either 2 or 4. All right, great. Well, that's going to do it for this problem. I'll see you in problem 4 next.